Hello everyone, in this video we are going to break down one of the most important parts of web security, that is how HTTPS certificates are created and verified. So we'll go step by step from how a website requests a certificate and how your browser verifies it using the chain of trust. So let's get started. So the first step is always that every website that wants HTTPS security first creates a public and a private key pair. So this is the website who wants HTTPS security and a certificate, and this is the certificate authority that is going to, give this website a certificate which is going to prove whether this website is authentic or not. So initially, this website is going to create a key pair, a public and a private key. What happens next? Initial key pairing is done, then it will launch a CSR request. This is, CSR request. It is this website is going to create a CSR request. CSR request is a certificate signing request. It tells the certificate authority that please give me a certificate. In CSR request, it gives the public key, which is it has already created in the step one. The public key, the domain name, the organization name, country, and the other information. So the certificate CSR is sent to the certificate authority here. So what happens next? So see, the certificate authority verifies the website's identity. Now, for example, just imagine a DigiCert is a famous certificate authority, and the Google has requested the DigiCert to give a certificate. So DigiCert checks if Google really owns Google.com or not. Depending on the certificate type, this can include, you know, uh, DigiCert can check the domain validation, can do organization validation, or they can even do the extended validation. So the domain validation is basically they checks they can send an email to the admin of that domain that whether this is you who's requesting for the certificate or not, or they can check the DNS records. So in organization validation is one step higher. If they want to go in details, they can check the government businesses records or calling the company that whether this is you or not. So if it is some bank or some financial based business, certificate authorities can go in more details and can go for the extended validation, which includes both domain validation and organization validation. For example, the banks or major companies like PayPal, for these companies, the certificate authorities satisfy themselves by going into such details and then verifying whether this is the original website which is requesting for the certificate or not. So once this CA verification is done, then a certificate issuance comes into the play. Now CA takes the details from the CSR. So these are those details, the public key, Bob's ID information, or CA information. So this complete details are fetched from the CSR, and now here's the cool part. Before sending it to the Google, the CA will create a hash. This is known as, by the way, these details are known as X509 form. So what is X509? It's an unsigned certificate. So this unsigned certificate is then what certificate authority will do is to create a hash of it. Once the hash is created, then they will encrypt that hash using certificate authorities like DigiCert's private key. So this becomes a digital signature. So once it is signed by this hash is signed by the certificate authority's private key, so now this will become a signed certificate. So this is now a complete certificate is formed, which is ready to be sent back to the website uh, to give that website an authority that or a certificate that they are original websites. So what happens next? So websites install those certificates. It's not always the one certificate. There are normally two certificates which are signed by the certificate authority. One is the website certificate, and the second is the intermediary certificate, which connects DigiCert or a certificate authority to a trusted root certificate authority. For example, let me explain you with um, here you need to understand that there are three basic certificate authorities. Number one is a leaf or an entity certificate, which basically creates your certificate to whom a website actually contacts. Then there is an intermediary certificate. Intermediary certificate is basically issued by a trusted certificate authority. Then there is a root certificate, which is not sent by the server because it is already stored in your browser. So root certificate is the most trusted one. It is in your browser. Then there comes an intermediary certificate, which is signed by the root certificate, or root certificate gives authority to the intermediate certificates to make further certificates. So this is, what you need to know here, that there are three basic certificate authorities. So what happens, like when you visit a website, now a certificate is created, sent to the website. Now what happens when a browser actually contacts that website who has got certificate? So so when a browser actually contacts that website, for example, google.com, your browser sends a connection request and the website replies with its own certificate, which we have just created, and second, the intermediary certificate. So the root certificate isn't sent because it's already built in your browser trusted store, pre-installed by your operating system. So what happens here? So now browser will basically checks whether these certificates are real or not. So it will play as detective. It checks the website certificate. Is it signed by a trusted certificate authority or not? If yes, then it uses, so this is the details which the browser gets in the form of a certificate. What browser will do, browser will, as we already said, that this signed certificate is signed by the certificate authority's private key. So now the public key, as we already said, that public key is with everybody. So browser has the public key of certificate authority, and it will decrypt this signed certificate and gets the information, gets that hash. It will recalculate that hash and comes up with the public key and these details. It will match these two details. If they both are equal, it means that the certificate is valid and unmodified. I hope you got this. So browser gets these three blocks and this fourth block. So this fourth block has to match with these three blocks. So once this fourth block is unsigned by using the certificate authority's public key, which is publicly available, so once this signed certificate is decrypted, it got the hash. You can see we already explained this. Here you can see before signing this, we had the hash of this complete data. So we got the hash here. So hash is recalculated, and we are with this information, the first three blocks out of this fourth block. So we can simply match both of the informations. If they both are equal, so the certificate is valid and unmodified. Then the browser goes to the chain of trust. If what the chain of trust is, so this is the general diagram of the chain of trust. So there are three basic certificate authorities, as we said. One is root, intermediary, and endpoint. Endpoint is the one which has created your certificate, or you can say certificate, basic website certificate authority. Then intermediate certificate, then root. Root is self-signed, already pre-installed in your browser. Root certificate signs the certificate of intermediary certificate. Why is there a need of intermediary certificate? Because root as is pre-installed in most of the browsers. So if root's public key or private key is exposed, it will create havoc. It will, there are only 80-90 trusted root certificates. If any of the root certificate is, you know, uh, is compromised, then so many websites, the certificates of so many websites would be, go in vain. So the root certificate basically signs the intermediary certificate. Intermediary certificate signs the endpoints, the certificate authorities as certificate. So each of these, certificates has their own public key in themselves. So once the root certificate, we open the root certificate, we get the public key of that root certificate. So this public key will be used to open this intermediary certificate, because we said that intermediary certificate is signed by the root. So root has signed it with root's private key. So once we got the public key from the root certificate, we open this intermediary certificate. From intermediate, once the intermediary certificate opens up, it will give us the public key of intermediate mediatory certificate authority. So this intermediate public key of intermediate certificate authority will be used to open the actual certificate of that website. So once that the actual certificate of that website open up, it will give us the public key of the website. So which we, initially, we discussed that this is the Bob's public key, which is the initial public key of that website. So once we are with the initial public key of that website, so we can simply match it with the public key of certificate authority, uh, in our browser. If they matches, that means the certificate this certificate is real and the website is trusted. So this is how this certificate chain of trust is unfolded, and this is how your browser basically validates whether the website is trusted or not. So there are so many other things. Sometimes the certificates are revoked. Sometimes there's no certificate in it. Sometimes hackers are playing with the certificate. So there are so many things. Um, which we'll be discussing in the upcoming videos. So if you've learned something new today, hit the like button and subscribe for more cybersecurity explainers. Thanks for watching. Stay safe online.